Today we're going to start our lesson on inverses. Okay? We're going to start by investigating inverses. First thing I want you to notice is what you're given. Somebody tell me what you're given.
Points.
A table, points. What else are you given? An empty graph. Okay? So number one, look at the ordered pairs in each table. What patterns do you observe?
Inverse. X and Y.
X's and Y's are flipped. That's what I heard. I saw a lot of hand motions, appropriate hand motions. That was good. Okay? But choosing words, I heard somebody choose these words. Does anyone agree with these words? If the question was, what patterns do you observe in these tables? Do you agree with these words? Okay? Do you think that these are the best choice of vocabulary for now?
Well, yeah, for now.
For now, yes. I agree also. Okay? Some of you are thinking of other words right now, and that's okay. But for now, this is perfectly appropriate. Okay? As long as you don't think that, like, a flipped 7 looks like that. You okay with that? Okay. Right. For each table, plot the points in order and connect them with line segments. Stop. Stop. If I said to you, plot this table on this graph, would you automatically connect them? No. We've learned that, right? This set of points is what? Discrete. Okay? For the record, I have to be honest, I laughed at some of you. Some of you inside my head, some of it came out of my mouth. Because on the words, especially the words discrete and continuous, when you had to choose that on your test, you spelled them wrong.
I'm sorry.
And the question said discrete or continuous. You didn't even have to look anywhere. You didn't even have to pull it out of your brain or somewhere else.
I'm sorry, because I know for a fact that I probably misspelled it once or twice.
You guys just made me laugh, and I'm just being honest. I didn't want to laugh at you behind your back. I wanted to laugh at you in front of your back. Okay? Okay? Okay, back to question 2. For each table, plot the points in order and connect them with line segments. So why am I allowed to connect these points even if we know they're discrete? It tells us to. Okay? So connect them with points. To help tell the two graphs apart, please use a different color for each. Hopefully you understand that I did not actually mean apart, but that's what I said. Okay?
It's okay for me to use a different color.
Yes, pens are okay right now because we just want 2 different colors. Again, light gray and dark gray are not 2 different colors. Connect them as you go, too. That's going to help. Instead of trying to go back later and figure it out. You got it? So, what are we going to write for number 2?
Nothing. Wait.
So what do I think if I see a blank question?
There was no question asked.
What am I going to think if I see a blank area after question 2?
That we
Okay. Write something. Some people, I don't think it was anyone in this class, but some people in their test, remember on that chart, I even gave you an example what to do. Some people still left stuff blank. And when I asked them about it, they were like, well, nothing happened there. On the review I showed you, on the test I gave you a sample, and what did I put if there was nothing there? No, or a dash, or something like that, right? Okay? We don't want to leave stuff blank. How are the two graphs related? Well,
they contain the same
they contain the same number of points? Yes. I'll go with that. Contain the same number of points. How else are they related?
They contain the same.
Well, they kind of look the same, but it's like rotated in a way.
Oh, rotated? You think it's rotated?
They're flipped.
Yeah.
It's flipped.
I flipped.
So here's one, right?
Yeah.
So if I rotate it 90 degrees, that gives me
I'll keep
that.
going.
Is that right? If I rotate it 90 more degrees,
It's flipped.
Reflected.
if I rotate it 90 more degrees,
Oh, yeah, you're right.
if I rotate it 90 more degrees, that just means my original, right? Okay, I also heard reflected. So if I reflect it over the y-axis,
Reflected and then
so if I reflect it over the x-axis,
See, now we can rotate it.
no, it wouldn't work. Wait, would it? Yeah, wait.
it is not a rotation.
So I can't rotate it at all?
I just rotated it every way you could.
Does the reflection have to
Can you say reflected
The reflection does not have to be over x or y.
Can you say reflected over y equals x?
Well, what is y equals x? Where'd you even get that?
That's just a straight line that's slow people in one counting.
Wait, how does that even make sense, though? Or does it?
It does.
Does it make sense that I would need to reflect it over the line y equals x? What did I do with my x's from table 1? I made them equal my y's. What did I do with my y's from table 1? I made it equal to my x's. So you're telling me right now that the transformation that occurs is a reflection?
Did you say that they have the same pattern? Or is that a bad word?
No, you could say they have the same pattern. That's good.
That's a bad word. You don't have to say it.
Someone give me the same.
Contain the same pattern. So let's go on to number 4, and we'll come back to what we were talking about in just a second, because it's what number 4 talks about. Okay? A line of symmetry runs between these two graphs. Trace it with a dotted line. Jonathan thinks that that line of symmetry is y equals x. That means when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. And so on. Right? So if I trace that with a dotted line, watch what happens if I reflect this over the line y equals x. It goes this way, right? Oh my gosh. It's right on top of it. How can you tell if yours does? Look, fold your paper right along the line y equals x. Your axes should be on top of each other. And then hold it up to the ceiling. Hold it up to the light. How many graphs can you see? How many graphs should you be able to see? just one. Because it should be right on top of each other. Okay? I heard Kiana say something. I need to ask her what she said. Say what you just said. It kind of looks like
Oh, it kind of looks like a bug.
a bug. Okay? I've always thought it looked like a bug or a spider. Last period they told me. It kind of looks like someone twerking.
I see it.
And you know what my response to that was?
Yeah, it does.
Wow. That was my response. Wow.
Well, now that you pointed it out.
Okay?
Yes.
So let's go ahead and fill in number 4, please. What is the equation for this line?
Y is X.
We already figured that out, right? But let's go ahead and write it down so we have it written down. Okay? Questions? On the box at the front, somebody please grab the other papers called Inverse of a Line. Please make sure everybody gets one. Please gets a paper called Inverse of a Line.
Miss Kingston, they said they were going to call Brandon out a few minutes to
What?
Okay? Traditionally, in years past, I know it's not you guys, definitely not you guys, but when we first start talking about the first question on this paper, called Inverse of a Line, people have a really hard time with this question. They think it's one of the hardest questions that I've ever given you. Give her one. I took hers.
Oh, we don't have any.
Why do you think that number 1 is the hardest question I've ever given people? Read it.
We don't know what M and B are.
They don't know what M and B are. First of all, once we figure out what M and B are, what's M? The slope, what's B? The y-intercept. Then, why is it still difficult? Because I didn't tell you what to write. You had to choose it your own self. Oh my goodness. Are there some more intelligent numbers than others to put here? Let's talk about the y-intercept first. Look at the graph that we are given. What would be an appropriate y-intercept for the graph that we are given? Somewhere in between negative 10 and positive 10, right? We don't want this to be 11. I can't even graph it. Please choose a y-intercept value between negative 10 and positive 10. And for the record, the closer you make it to the edges, sometimes the more difficult it is to see.
0.
I would prefer that you not choose 0, but you can if you wish.
And this slope be 1.
I would recommend that you keep your y-intercept between negative 10 and positive 10. Okay? What about a slope?
2, 3, 4. Path.
I would keep my slope somewhere between positive 5 and negative 5. Any more than that, you're not going to be able to see it very well. Okay? But I do need, for our intended purposes today, I do need some people to volunteer to make a negative slope. Can I have 2 or 3 people volunteer to make a negative slope? I don't need 6, but thank you. I need volunteers in a minute, so hold on. Okay, so 3 people. I also need somebody to volunteer to make your slope a decimal or a fraction, like a half. Can somebody do that? You got that? Okay. Okay. Write the numbers that you choose in the box. No, I will not tell you exactly what numbers to choose. Choose yourself. Okay? Once you have these numbers in the box, please use your equation to complete the table for the original line and then plot the points to construct the graph. Do it. I'm also going to do one so that we can have one to talk about together. Okay? Okay, is everybody good? Now, I wrote down my original. Okay, did you guys see how I did my problem, by the way? I actually did mine backwards, first of all, than the direction says, and actually backwards than some of you. Some of you did it the same way I did.
I have the same numbers as me.
I plotted my line first and then wrote down my points. Is that okay?
Yeah.
Okay. Some of you figured out the points and then plotted them. Some of you even used your calculator and you put the equation in here and went and looked at the table. Okay. What I would recommend, please, if you do this, if you use your calculator, don't just automatically start at 0 and look at the table. Because if we automatically start at 0 and look at the table, we may not get the most appropriate points. Okay? Some crazy kids last period were like getting like 11 and 17 for their Y values. And that doesn't even help me on graphing those points, does it? So if you're going to use the calculator, which is just fine, adjust your table. You have to be smarter than the calculator, right? Adjust your table so it's points that make sense. All right? Now, I just gave each one of you one of these. Okay? This is called a mirror. No, I'm not pronouncing it incorrectly. I know this thing right here, this thing is called a mirror. Right? This thing is called a mirror. M-I-R-A. Okay? We need to have some guidelines about these. Let's go ahead and all put them up to our eyes and look around so that we can all do that at once and get it over with. I would also ask you, please don't put these in your mouth. You say that, and I'll look up, and one of you is going to be sitting here with it in your mouth like this, back and forth. Okay? Please may I give you a warning? Please may I give you a warning? That's gross. Okay? Now, for all but 9 of you, we used these last period. Okay? But the rest of them, I Cloroxed them before I put them back in the box after we used them last year. Okay? So they should be clean. Hopefully there's not any Ebola on them. Okay? Pretty sure there's not. Now there is, now that you put it in your mouth. Excellent. Okay? So what we're going to do with these is we're going to follow the directions on number 3. Place the mirror along the line y equals x. Please notice, however, there's 2 different edges. One of your edges is beveled. Can you see the difference between this edge and this edge? Put the beveled edge down. Okay? Now, this is really hard to see on the screen, so if you're watching this video on the screen, I'm sorry, it's not going to be easy for me to explain what I'm doing. Okay? It's much easier to watch. Okay? Me actually doing it from the side, not from the top. Okay? I am currently, and I don't even think I can adjust it so you can see. Maybe that's pretty close right there. Okay? What I'm going to do is I'm going to look at this side. When I look at this side, I can actually see my reflection, the dots. Can you see right there? These dots right here in my reflection? I'm going to try to trace those dots. Hold on, I got to put it back on my paper. I'm going to trace those dots. Merry Christmas. Like that. Okay? And then I'm going to look at the other side. So I can see my reflection on that side also. I'm going to trace those dots as well. That wasn't as pretty. So my paper ends up looking something like this. Am I expecting perfection? No? You'll see in just a second it'll be close. Okay? So how are we going to answer number 3?
My hands are too.
Okay. We'll come back to the line we've just drawn in just a second. We'll come back to it. Okay? Right now we're on number 4. Number 4 says record the coordinates from your reflected line in the table on the right. Okay? So that means I got to straighten my line up just a little bit. And I've got to record the points over here. -1 maybe. 5, -2. 7, -3. Right there. -2, 1. I'm having a hard time seeing mine. Are you having a hard time seeing yours? That means we must have done it wrong. No, this is an experiment, right? We're figuring stuff out. Okay? So write a couple of them down. Do you see any patterns? Yeah.
It's -1. So is it going to be the same?
We'll talk about yours in just a second. Okay. Okay, look. Do you notice this? Look at this particular point on my table. Look at this particular point on my table. That one's not exactly, but it's close, isn't it? Go ahead and flip this table. Switch your X and Y. Write it on the outside. And plot those points on your table. Please don't make it in the same color that you drew your line. Okay? Now is it a little easier to see a pattern? I know that your numbers are different than mine, most of you, right? But do you see a pattern? How did we get the reflected line table that we drew in? How did we get it? How did we get from this table to this table? Yeah, several of you are showing me with your hands. Again, appropriate hand motions. But say it in words, please. X and Y are switched. Now, in our previous worksheet, we said X and Y's are flipped. Now we're saying X and Y's are switched. Are we okay with that? She's okay with it. Is anybody else okay with it? Besides me? Yeah? Hopefully? Okay. Is the line, is the reflected line a function? Why or why not? Is my green line, can you tell this is green and this one's orange? Is my green line a function? Yes, because?
I don't know the words. The words aren't coming.
No, X's repeat. That's one argument. What's another argument? Passes the vertical line test. Okay? Are yours? Is everyone's a function? Look at this crazy kids. The first line he drew was the orange one. The second line he drew was a blue one. Did he do anything wrong? If I folded this along the line y equals x, would they be on top of each other? But his second equation, is that a function? No. So what would he put on 5? No. X is repeat. Wait, so we could have different answers on the same question? What? Yes, wait. Angelica, let me see yours. You guys need to see hers. Okay? She clearly does not follow directions.
Miss Kings,
Right? Yes.
can I have Ryan braid?
Can you wait about 5 minutes?
Yes.
Thank you. Angelica does not know how to follow directions, does she? She chose a -1 as her x value, as her m value, and a 3 as her y-intercept. Wait a second. Karina doesn't think she did anything wrong. Anybody else think she didn't do anything wrong? Besides me?
I don't think she did anything wrong. Miss Kingston.
Here's mine. Mine reflected over the line y equals x. Here's this one. It reflected across the line y equals x. Doesn't this one reflect across the line y equals x?
Yes.
Just because there's 2 graphs doesn't mean she did anything wrong. What's special about this equation?
It reflects over itself.
It reflects onto itself because isn't it perpendicular? They have opposite reciprocal slopes, don't they? So it's perpendicular. So when she folds it over, guess where it's going to be? Right on top of itself, isn't it? Okay? Any questions about that? Look at the back, please. Thank you. Good job. Compare your graphs and tables with others in your class. Oh my gosh, I wish I would have thought ahead and put you in partners. Please compare yours with your partner. After you compare yours with your partner, stand up and go find another partner pair and compare yours with theirs.
Hayden, I wanted to keep it your house.
You and your partner go together to another set of partners. You and your partner go together to find another set of partners.
I still thought so.
Please return to your seats. Please return to your seats. Now please make some observations. Question number 6 says, compare your tables and graphs with others in your class. What observations can you make? Yours was the prettiest, okay?
Everyone's graph was different, but we all way to do the same thing.
Okay, so everyone's graph was different. But what?
We all managed to follow the same instructions.
All were reflected. Whoa. All were reflected over y equals x. Think back to the engage activity. The twerker. How is the graph from this activity right here, the twerker graph, how is it alike or different from the graphs on this side, in the numbers 1 through 4? Okay, I'm hearing different things first. More complicated. Oh, this first one was not a function? Say it one more time, please.
The reflected graph wasn't a function.
Neither one of them were they? The original function, or the original graph wasn't a function right there, was it? Okay. How are they the same? Anyone seeing a pattern here? Look at just the tables, not the graphs this time. Just the tables from this activity and from this activity. What can you tell me about the tables? X's and Y's were what? Flipped. Why did I say flipped? Why did I write flipped? That's what he said, isn't it? So I want to give value to what he said, and then we need to decide, is that correct vocabulary? Yeah.
Yeah, well, yeah. Not the best.
Okay. So we have quite a bit of room down here at the bottom. There's one more thing I want us to add. Please add it like I do. Okay? X's and Y's. Flip. Or switch. Or flop. It says it here. It says it here. It says it here. It says it here. Do you think that's going to be a big deal when we talk about inverses of lines? Yes. Okay? So, for your homework tonight, I need you to complete these 2 worksheets right here. These 2 worksheets. Complete them. That is your homework.